All right, we're starting linear equations in one variable in section 9, and you can pause the video right now and take a look at the objectives for this section, but we are doing a whole bunch of stuff with linear equations except for graphing. We will not be graphing quite yet. So the first thing we're looking at is identifying linear equations in one variable, so just figuring out what it is just by the situation. So the example here is imagine you're riding your bike away from home at a steady 10 miles per hour. And you're 5 miles from home. So we're starting at 5 miles away. So that means at time 0, so this is how algebra always begins, at 0, it's the easiest way to think of it, the distance is already 5 miles. Okay, so we're starting 5 miles away at time 0. Now, after an hour, how far have we gone? Well, if we're going 10 miles per hour, that means we go 10 miles every hour. So from here to here, we add 10 miles. Okay, so that's going to be 15 miles. At hour 2, we're going to add another 10 miles. So that's going to be 25 miles. And at 3 hours, if we really have it in us to go that far and not stop, we will have gone 35 miles. Okay, so what we want to do is we want to come up with an equation for this. An equation for this situation. And so we're going to use d for distance. And usually you want to use variables that make sense so you can kind of remember what it is that they stand for later. So the distance that you go is going to be equal to the distance created by moving, so that's 10 miles per hour, times the time. Okay, so if you think about it, after 1 hour, you've gone 15. So you start with 5 though. We don't start at 0, so this isn't quite right. So now we have to say, well, we started at 5. Now this is going to give us our correct equation. So this right here is our starting point. Starting point. And the 10t, this here, is our distance that we move, distance by moving over time, okay, dependent on time. So you think about it that way. It's dependent on time because the longer I move, the farther I go. So now instead of a table, we can use the equation that we created to figure out how far we go after a certain amount of time, or we could even figure out how much time it would take us to go a certain distance. So the first question that I have for you is how far, what is your distance after, let's say 5 hours, 5 hours. How far have you gone? So, well, t equals 5, and d, the how far, is the question mark. And I really recommend that you do this. Most people have a hard time going from words to equations. This part right here that I've just done, d equals question mark and t equals 5, that is the key to really understanding how to use equations. So in this situation, we've got d equals 10t plus 5. So t is 5, so we're going to say 10, and we're going to use parentheses to show that we are putting a number in for t, and then plus 5. So this is 50 plus 5. Which is 55. Now think about what the units are going to be. This is going to be miles per hour times hours, which the hours are going to cancel out, and this is also miles. Okay, so the answer is going to be in miles. So think about these before you answer them. Think about what distance is. It's not miles per hour. It's not hours. It's miles. Okay, so now we're going to talk about the general equation for the linear equation in one variable. So the general form of the equation is ax plus b equals 0, where a can't be 0. So, of course, if a is 0, there would be no x because it would go away. So this is what we want it to look like. And one thing I want to point out is that linear equations are going to model things that move or change at a constant rate. So this is really key right here, at a constant rate. So it can't be speeding up or slowing down. All right, so we're going to look at examples of linear equations. So we want to look at first, are they a linear? Next, we're going to look at are they a linear equation. Right now, we're going to look at how to put them in the correct form so that we can then work with them. Okay, so we're going to put them in the form ax plus b equals 0. So in this situation, we need to subtract. And I'm going to give us a little space down here. We don't need that orange box anymore. So let's look at this first one, x equals 0. Or x equals 1. And we want it to equal 0. So we want 0 to be over here on the right. Ax plus b equals 0. So we want to subtract 1 from both sides. And we get x minus 1 equals 0. So that is now in ax plus b equals 0 form. So x minus 1 equals 0. So what is a? There's something in front. There's a coefficient in front of x. It's not showing. So it's a 1. So that's 1. And what is the coefficient of b? Well, it's minus 1. Or what is b? b is minus 1, negative 1. Okay? So the next one is negative 5x plus 4 equals 3. It's almost there. So if you look at ax plus b equals 0, ax is first, and then this looks like b, but it's not because this side over here needs to be 0. So we're going to subtract 3 from both sides. And we get negative 5x plus 1 equals 0. So now we've got negative 5x plus 1 equals 0. So what is a? A is negative 5. That's the coefficient in front of x. B is the constant term. And sorry, I said coefficient just a second ago. It is the constant term. So that is just a 1. And now we've got the whole thing filled out. We've got one more to go. So this next one is 2.5x equals 0. Well, it's already said equals 0, and we already have a coefficient in front of x, but what's missing is b. So in order to put it in the form ax plus b equals 0, we have to write 2.5x plus 0 equals 0. Okay, so that we can see what everything is. Okay, so 2.5x plus 0 equals 0 is what we're going to write in here. So a then is the coefficient in front of x, 2.5, and b is the constant term, so it's 0. Okay? So all of these equations are linear equations, even though some of them have things missing, or they're in a strange form. Once you've written them in the form, you can see what a and b are, and so you can see that they are all going to be linear equations. Equations are not linear when these following things happen, and this is very important to know for the future of your math career, and also just things you need to know for this class. So an equation is not linear if the exponent is something other than 1, and I mean the exponent on x. So if x is like x squared or x cubed or anything like that, it is not going to be linear. If it appears in the denominator of a fraction, so if it's 1 over x, so if you have 1 over x, or if you have 5 over x, or if you have 5 plus x over x, okay? So anytime you see an x in the bottom of the fraction of a rational expression, it is not a linear equation. So the last one is if it appears under a radical sign or within an absolute value. So if you see something like square root of x or square root of x minus 3 or anything like that. And if it's in an absolute value. So again, if it's just an x in there, or if it's, x plus 7, anything like that. So if the x is inside the absolute value or inside the radical sign, it is not linear. So all of those things are very important to know. Make sure they're in your notes. Okay, I'm going to give you some think time on these so I don't just tell you the answer, because I think these are fairly straightforward. But the first one, 4x plus 5 equals 0. We're being asked, are they linear? And if they are, write it in the form ax plus b equals 0 and figure out what a and b are. Okay, so the first one, is this linear? The answer is yes, it is linear. And it's already written in the correct form. It's ax plus b equals 0. So a equals 4 and b equals 5. That one's pretty straightforward. All right, the next one, is this linear? And yes, it is. It is linear. X is not raised to a power. It's not in a denominator. It's just multiplied by a fraction, but it's not in the denominator, and it's not in a radical. So it is a linear equation. So we're going to rearrange this, and we're going to get, I'm just going to subtract 5 from both sides, just to keep it simple. Subtract 5. And we could get, then we will get 0 equals negative 3/4 x minus 5. All right, is there another way to do this problem? Yes, there is. You've got 5 equals negative 3/4 x, and you can add 3/4 x to both sides. So I would say plus 3/4 x plus 3/4 x, and you would get 3/4 x plus 5 equals 0. Strangely, both of those are going to end up giving you the same answers because they're set equal to 0. So in this case, A is 3/4 and B is 5. And in the other case, A is negative 3/4 and B is negative 5. And both answers should be correct. I don't know about our online homework system, but I will count it correct. All right, this next one, is this a linear equation? And the answer is no, because we have this raised to a power of 2. So that is not a linear equation. All right, let's look at the next one. 3 over x plus 5 equals 0. So think about that one. This one is not linear because x is in the denominator. So the answer again to this one is no. All right, so next you're going to be trying some. So give these next few a try, pause the video, do the same thing that we just did, and try to see if you can come up with the answer, and then come back and check the answers after you've tried it. Okay, so this next one, A, yes, it is linear, and it's already written in ax plus b equals 0 form. A is negative 3, b is 7. The next one needs to be rearranged so that it equals 0. So you're going to subtract 5 from both sides. Get 1/2 x plus 2 equals 0. So it is a linear equation. A is 1/2, b is 2. C is not linear because x is under the radical. D is not linear because x is raised to the power of 4. Okay, so the next thing we're going to talk about is solving linear equations. The first topic within that is solving with tables. First, let's talk about the fact that every linear equation has exactly one solution. Exactly one. Okay? So that's pretty important to understand. Solving a linear equation means finding that one value that makes the equation true. Okay, so the first topic under this is solving with tables. I don't talk about this every time it comes up because it just keeps coming up, and it's not my favorite way to solve an equation. I think it's rather tedious, actually. So let's look at it one more time, how to do this. So we're going to use a table to solve 2x minus 5 equals negative 7. So there's some x that would make this true. Okay, so the way we use tables is we say, all right, well, what would 2x minus 5 equal if x was negative 3? Well, it would equal negative 11. What would it equal if x was negative 2? So you're going to say 2 times negative 2 minus 5 equals what? So that's going to be negative 4 minus 5, and that equals negative 9. So we'll put negative 9 right here. All right, the next one is 2 times negative 1 minus 5, and I got the negative 1 from right there. So we've got negative 2 minus 5 is going to be, sorry, that's a negative 9, negative 7. And we're going to go on and do the next one is 0. So 2 times 0 minus 5 is going to be 0 minus 5, which is negative 5. And perhaps you are seeing what's happening here. Each one of these is going down, or actually up, by 5. I'm sorry, by 2. I keep misspeaking today, sorry. So we go from negative 11 to negative 9 to negative 7 to negative 5, and those are going up by 2. So that's going to keep happening. You can plug these in and check if you would like. but you get all the way up to 3. So I'm going to check the last one just to see if it's true. So I'm going to say 2 times 3 minus 5 equals 6 minus 5, which is 1. So the pattern did follow all the way to our last. Add 2, add 2, add 2. Okay, so that only is true for a linear equation. All right, so to solve this, we're going to look for the one that equals -7, and that is this one. So we want to see where 2x minus 5 equals, so equals -7, because that's what it is. So that means that x equals -1 is our solution. Okay, so and you can check it one more time and see if that's really true. X was -1 minus 5, that did equal -7. And if you're looking for a solution, you can just stop there and not continue filling in the table. Okay, so the next problem is for you to try. So you're going to use a table to solve -2x plus 1 equals 3. Pause the video, give it a shot, and then come back and look at the answer. So I went ahead and filled all this out so you can take a look at plugging in -2, -1, 0, and 1 in and make sure you have the right thing. It should follow a pattern, so it subtracts 2 each time. So as you go from this one to this one, you subtract 2, and this one to this one, you subtract 2. That's a linear equation. So now what we want to find is which one equals 3. So that's this one. And that means that the solution to this equation is here. That means that x equals -1 is the solution. So now we're getting into the algebra that you are going to use most often rather than tables. But this is solving a linear equation symbolically. So these are the steps. If you do not excel at algebra, I would take some time to look at these steps. I'm not going to read them to you, but maybe pause the video, write them down in your notes, do whatever you need to do, but just understand, that you're going to use the distributive property first, combine like terms, addition property, combine like terms, multiplication property, combine like terms. And remember, multiplication and division are kind of the same property, so you use those together. And then at the end, it's always really important to check your answer, especially when you're taking a test. So I'm amazed at people who put an answer down on a test and just move on. So make sure you check your answers because it's pretty easy to do. Okay, so now we're just going to practice solving linear equations. And again, if this is not your strong suit, make sure you do all of the try-its. All right, so we're going to start with A. We've got 10x minus 13 equals 0. We have no parentheses to deal with, so we're going to go ahead and do the addition property. So we're going to say plus 13, and we get 10x equals positive 13. All right, so now on the last quiz and test, I saw tons of people at this point say minus 10. You cannot get rid of the 10 by subtracting. It is multiplied times the x. So the only way to get rid of this 10 and isolate the x and get it by itself, which is the goal here, we're trying to isolate x, okay? So think of it as peeling away an onion. We're going to start just peeling things away from it, and the last thing we've got at the closest thing to the x is multiplied. So the only way to get rid of it is then to divide, okay? So we get x equals 13 over 10. All right, so the next one is every one of these is a little bit different. So we've got 1/2 x plus 3 equals 6. So again, there's no parentheses, so we can just start by using the addition property. We're going to subtract 3 from both sides, and the goal is to make it subtract away on this side. So we get 1/2 x equals 3. So now, these two are multiplied together. There's a couple different ways to think of this. One, you can think of this as x over 2, and then multiply both sides by 2, or you can think of this as a fraction, and we're going to multiply. Now remember, you can't subtract the 1/2. You have to multiply it or divide it to get rid of it. So 1/2, if you think of it as a fraction, we're going to multiply both sides by 2 over 1. And when we do 2 over 1 times a whole number, we can just say 2, but 2 over 1 if you want to. And now the 2 and the 2 are going to divide out or multiply out here. And we are left with x equals 3 times 2 is 6. So go back and think about it before you move on. 1/2 of 6 is 3. Is that true? Yes, that's true. Remember, multiplication with fractions means of. 1/2 of x is 3. All right, so x equals 6. So they want us to check our answer for this part right here, so let's do it. Let's go and put the answer back in. So I'll do it in a little different color here. Let's do 1/2 times 6 plus 3 equals 6. So I went back and I'm using this original equation to do this. So let me give us a little bit more space here if I can, if it's going to let me. I don't know. There we go. 1/2 times 6 is 3. 3 plus 3 equals 6. Is that true? Yes, it is, and it checks. Okay, so that's how you check. Do it on tests. It will pay off. All right, the last one, C, is 5x plus 7 equals 2x plus 3. Now, this one has basically what looks like a linear equation on both sides, so two linear equations set equal to each other. We need to isolate the x on one side and the constant terms on the other. Okay, so you can deal with either one first, it doesn't matter. So I'm going to subtract 2x from both sides to get the two x terms together. Okay, so they're going to cancel out over here. So I've got 5x minus 2x is going to be 3x. Don't take the x away. The x is still there. We've got 5 x's minus 2 x's. That leaves us 3 x's. All right, so now we've got plus 7 equals what's left on the right side is 3. Now we're going to subtract the 7. And we're going to get 3x equals 3 minus 7 is negative 4. Okay, so now we've got 3 times x. How would we get rid of the 3? We're going to divide. And we've got x equals negative 4/3. All right, so now it's your turn to give it a try. So let's keep doing what we've been doing here. And give these a try with the video paused and come back and look at your answer. Okay, so here's all of the answers to these problems. You're going to just take a look at all of these if you could, and go through and make sure you did every step right. I'm not going to talk through each one, so pause it as I move through these and make sure you've got all the parts. And on part B, it asked us to check, so I showed you how to check here on the right.